This is 12.1b, sine, cosine, and tangent ratio to find sides and angles. Let's take a look at the tangent ratio. It is defined to be the tangent of the acute angle in a triangle is the opposite leg over the adjacent leg. So here's angle A, and it'll be the length of the opposite leg over the length of the adjacent leg. There are two other ratios called sine and cosine. The sine is, here for sine of A, it's the opposite leg over the hypotenuse, and the cosine of A is the adjacent leg over the hypotenuse. Many times we help students by using this mnemonic SOHCAHTOA, where this is the sine and the ratio is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Let's go ahead and use SOHCAHTOA, SOHCAHTOA, and we're going to look at angle S. Now the opposite leg is 80. So here, opposite over hypotenuse, that would be 80 over 82. Now cosine is adjacent for angle S, and this is the adjacent, which is 18 over the hypotenuse. The tangent is the opposite. We know what the opposite is. It's 80, and the adjacent leg is 18. Now let's take a look at angle R. Now for angle R, this is the opposite. Keep that in mind. So for sine, it's opposite over hypotenuse, which is 18 over 82, and cosine is 80 over 82, and tangent is 18 over 82. Now all of these should be reduced. I'm not taking time to do that right now. Okay, your turn. Let's pause and see what you can do. And here are the answers. Let's use special right triangles to find the tangent of 60 degrees. So we're going to write SOHCAHTOA, and we're trying to find the tangent of 60. Now this is the angle we're using, and this is the opposite. Remember, it's the opposite leg, which is root 3, over the adjacent leg, which is 1. So the tangent of 60 is root 3, and if you put that in your calculator, it's about 1.7. Now let's figure out the tangent of 60 for the other triangle. And again, this is 60. Here is the opposite leg, which is 2 root 3, and the adjacent leg, which is 2. And then this is root 3, so it's coming out to be the same. So no matter what size this 30, 60, 90 triangles, they're all going to be similar triangles, and they're all going to yield the same ratio. So the tangent of 60 degrees always has the same ratio. Now, before calculators, we used to have tables, and in these tables, we were told what these ratios were, that we had decimals, 4 decimal places. So let's go ahead and solve this problem and use what we did in the past by using our tables. So we want to figure out what x is. Here's the angle. Looks like we have an opposite leg, and it looks like we have an adjacent leg. So this tells me we are going to use tangent. So we're going to say the tangent of 32 degrees is equal to 11 over x. Now the tangent of 30 degrees is right here, but I'm not going to substitute it in yet because that is kind of awkward for me to write. But what I am going to do is I'm going to write over 1 here so that this looks like a proportion. And when this looks like a proportion, I can actually cross multiply. So this will be x times tangent of 32. Now tangent of 32 is a number. It's this number right here. I'm just not choosing to write it. Now I want to get x by itself, so I'm going to divide both sides by tangent of 32. And that's a number I'm reducing. And so x is equal to 11 over tangent of 32. So I'm going to put this in my calculator, but not yet until I substitute my tangent, which is 0.6249. And when I do that, I'll just go ahead to my calculator now. 11 divided by 0.6249. And I'm going to round to the nearest tenth, and the answer is 17.6. 17.6 kind of makes sense to me because this angle over here will be 58 degrees and the side opposite a bigger angle should be bigger. So that looks good. Okay, let's go ahead and take a look at finding the sine and cosine of this. And we're going to now use our calculator instead of a table. Okay, so I want to figure out, I'm going to use 27 here, or 26, and I'm going to use the opposite leg, and then I want to use the hypotenuse. I don't want to use y, I want to use one variable. So this is going to be the sine of 26 degrees is equal to x over 14. Okay, I'm not going to go to the calculator yet. I'm just going to put this over 1, and then I'm going to cross multiply, and this cross multiply is going to look like this. All right, now I'm going to use my calculator, and it says calculator must be in degree mode. So when you go into mode, make sure it's in degree right here. And now I'm going to do second quit, and then I'm just going to type here 14, and then type in sine, and I know it's in degrees, and then I press enter, and the answer to the nearest tenth is 6.1. So x is approximately 6.1. Okay, now I want to figure out what y is, and to figure out y, this is an adjacent, so I'm going to use cosine. Cosine of 26 is equal to y over 14. And so over 1, I'm going to cross multiply. Y is equal to 14 cosine of 26. Okay, I'm going to go to my calculator, and this time I'm going to type 14, but press cosine, and 26, and then press enter, and I'm going to get 12.6 when I round. So y is approximately 12.6. Now this makes sense to me because this will be 64 degrees, and this side right here is 6.1, and this side over here is 12.6, so it looks reasonable. Okay, let's take a look at an application. We have an angle of elevation. This angle is where we're looking up, and we'd like to figure out the height. Now notice that we have an opposite, and we have an adjacent leg, so this looks like a candidate for tangent. So this is the tangent of 59 degrees is equal to h over 45. I'm going to make this look like a proportion, and then I'm going to cross multiply. And now at the very end I use my calculator, so I'm going to go 45 and then press tangent of 59 and then enter, and my answer to the nearest foot is 75. So this is 75 feet. So you need to take a look at what they ask you to round to. Your turn. And here's the answer. Your turn. And here's the answer. Let's take a look at finding angles. We were finding sides. Now let's take a look at finding angles. So if tangent of A is equal to x, and you want to isolate A, isolating A means you're going to have to take the tan inverse of x. So we're going to take the inverse of the ratio, and that's going to give us our angle. Let's take a look at how to do that. Okay, so now instead of finding a side, we are looking for an angle, and we're going to use the calculator to help us do that. Okay, well, in the old days, when we didn't have calculators, what we had is tables. So here's the tangent of A is 0.75. And in this column of tangent, I want you to notice that 0.75 is between here and here. So if we go across here, the answer should be between 36 and 37. So angle A is between 36 degrees and 37 degrees. Now here is sine. We're looking for the angle. 0.87 is between these two numbers. That's the sine. So I know angle B is between 60 degrees and 61 degrees. So this is the closest we could do it when we were before calculators. We could only see what it was close to. Now let's take a look at using the calculator where we can be a lot more accurate. So to figure out angle G, what we want to do is take the inverse. So we're going to write measure of angle G is equal to, and then we're going to write tan inverse. That means we want to do, we want to find an angle. We don't want to find a ratio. All right, now we're going to go over to the calculator. And the tan inverses are above these trig functions, so you have to press second, tangent, and then we're going to put 0.43, and instead of going to a table, the calculator will actually give us a lot more accurate answer. So the answer to, and they want us to do it to the nearest, let's see, 1/10 of a degree, so it's going to be 23.3 degrees. So 23.3 degrees will be measure of angle G. Now to figure out the angle here, we're going to isolate H, and we're going to use this inverse process. We're going to get a lot more accuracy. So the measure of angle H will be, I'm going to do sine inverse, second, sine inverse of 0.68, and we're going to do it to the nearest 1/10, 42.8. So this is going to be 42.8 degrees. Okay, your turn to do the next one. And here's the answer. Let's take a look at solving a right triangle. What does it mean to solve a right triangle? It means that we want to find all the side lengths and angle measures. You can solve a right triangle when you know either of the following information: 2 side lengths, 1 side length, and the measure of 1 acute angle. In a right triangle, you must always have at least 2 pieces of information, and one of them has to be a side. Okay, so let's take a look at solving this triangle, which means we want to know all 3 sides and all 3 angles. So we know AC, and AC is 2. BC we know is 3, and we're looking for AB. We know that the measure of angle C is 90, so we're looking for the measure of angle A, and we're looking for the measure of angle B. This is what it means to solve. You want to know all the information. So to solve for C, we can use the Pythagorean theorem. So we're going to do C squared is equal to A squared plus B squared. So C squared is equal to 9 plus 4. I'm just squaring in my head. So C is root 13. And it says to round to the nearest 10th. And so I'm going to take root 13, and that's going to be about 3.6. All right, now what I want to do is I want to find measure of angle A. So here is A, and I'm not going to use my C because if I got it wrong, then my A is going to be wrong. But I do have an opposite, and I do have an adjacent. So, TOA. So it looks like I have a tangent. So the tangent of A is equal to 3/2. And we just talked about how we find these angles. It's with tan inverse. And we're going to do approximately. So it's tan inverse. So second, tan inverse of 3 divided by 2. And enter. And this is 56.3 degrees. Okay, 56.3 degrees, which is right here. 56.3 degrees. Now I would like to find the other angle. I don't really have to go through this because I know that all 3 of these have to add up to 180, or that these 2 are complementary. So what I'm going to do is I'm just going to say 90, take away, answer. So I'm taking away this previous answer, and the answer is 33.7 degrees. So this is 33.7 degrees, and some of you girls might be able to just do this in your head. Pause to do the problems, and here are